Okay, next video. All right, if this is January 2019, then this is the first class I've made this video for, and you're watching this because I have a sub for the first 2 days of the semester. So sorry about that, but congratulations, you're the pioneers for this video. All right, anyway, this is an Algebra 2 trig unit combined with a geometry unit, and we're going to kind of go back and forth between some geometry stuff and some Algebra 2 stuff. But the first day here is all from Algebra 2. And it's about functions and stuff. Yes, the whole unit is about functions and transformations. So we do functions and transformations in geometry, and we of course do them also in algebra. So this is one of the best uses of integration for the two things for the whole year. Okay, so first of all, there's these terms. There's the term function and there's the term relation. A relation is pretty much just any set of ordered pairs or any kind of I guess list or even infinite kind of list of x's and y's that are associated somehow, and that's just called a relationship or a relation. A function is a special type of relation. A function is when there's a list of x's and y's, so that for every x there can only be one y. I'm going to say that a lot in different ways throughout the unit, so you'll probably get bored of that after a while, but a function is limited in terms of what x's and y's you can kind of have in there together. But for every x, there's exactly one y. We'll just start there. Okay, so is this thing a function? Is this thing a function? Well, this thing appears to be a function because for all the points along here, whenever I think about what the x-coordinate might be for anything, it looks like, well, yeah, there's only one y that might go with that. There's like, if it's -1, if x is -1, y has to be 1. If x is 3, y has to be some number up here. There's never any point where I've got some x value and it's kind of like, well, there could be more than one y value. Some people call this the vertical line test. Let me try something. Here we go. I've got this vertical line, and you can kind of think about, well, every point along this vertical line are the points that would have the same x value. As I drag this vertical line around through this function, or through this potential function, there's no place where it crosses twice. And this is like checking all the values for the same x in the plane, really. So there's never any point where there's never any place where I can see an x value that goes with more than one y value. In contrast to that, if I think about that over here, there are some x values, like this one here at -2, where there are two different places that have the same y. So there's a point -2, negative something, and -2, positive something. So there are two different values that have the same, sorry, two different y values that have the same x. Like here it looks like I have 5, -2, and 5, 4. And that is not supposed to be what we use as a function. So just to be clear on the terminology, yes, they're both relations, but this one's a function and this one is not. All right, let's see if these are functions or relations. So here they just gave us a list rather than telling us, like giving us a graph. For all the different x's, and a function or a relation could just be this small. It could just be that there's 5 little kind of finite points and that's all there is to it. For every x here, there's only one y until we get to 3. 3 goes with 8 and 3 goes with 10. This is a problem. This makes it no. This one, 0, 2, 4, 6, 8, none of these inputs come with more than one output, so that's not a problem. Here, sometimes you think about a function as a function machine. If I put 3 into this function machine, there's some kind of question about what can come out of it, and that's what kind of breaks this as a function. So I would say these things about those relations. Okay, function is called the one-to-one. If it kind of goes backwards and forwards, it's called one-to-one if it's a function kind of both directions, is one way to say that. In order for it to be a function, for every x there can only be one y, and for it to be one-to-one, then also for every y there can only be one x. So it has to kind of be a two-way fair street that way. For functions, it's okay if two different x's have the same y. But for one-to-one, it's a little beyond that. So they have this little Venn diagram here. Like the set of all relations is this big thing. Within that is the set of all functions. Those are the ones that are kind of special in terms of for every x there can only be one y. And then among those, there's a more special group, one-to-one, where for every y there's also only one x. So which one of these are one-to-one? Well, first of all, are they all functions? Actually, they're not. C is not even a function because, I'm going to change the color of this. Whoops. Change the color because it would be a little more snazzy. I can make it bigger too, that'd be fun. This is not a function because I have this problem. So this is not a function. So let's just forget about that one right now. But this one, everybody's happy, right? Because for everything in this kind of domain set, this x over here, it only leads to one y. And if we had to go backwards, which is also a feature of one-to-one, if I had to figure out where this came from, there's only one place it could have come from. Here, every x only has one y associated, which is fine. I don't know why this -5 is here. Maybe for consistency. But if I had to figure out where they came from and kind of go backwards for every y here, no, for this y, there's more than one x associated with it, so that's not one-to-one. Let me write those in. So again, since all of these things are lists of x's and y's, they're all relations. But the first two are functions, the last one's not. The first one's not one-to-one, but the second one is. Okay, line test for functions, I already talked about this. I kind of let the cat out of the bag a little bit like that, but on vertical line anyway. Vertical lines are a good way to kind of test every x value at the same time, or test x values as we kind of slide this vertical line and say to ourselves, well, is it that for every x there's only one y? And if so, if the vertical line only ever crosses once, then it is a function. Horizontal line test will examine y's one at a time. And if we slide that, let me try doing that. If I take this horizontal line and I slide it around, oh, can I grab it? If I take this horizontal line, I slide it around, it's like I'm examining y values. Like this is all the coordinates that have the same y value. And if I can slide it to the point where it's crossing this graph more than once, it's saying, okay, well, there's some values here. There's some coordinate pairs in this function that have the same y value for different x values. And so, yeah, this thing's a function because it passes the vertical line test, but it doesn't pass the horizontal line test, so it's not one-to-one. If it passes both those tests, it's a function and it's one-to-one. Okay, domain and range. Domain and range are just vocab terms that have to do with the set of all x's and the set of all y's, essentially. So the domain is all the inputs, it's all the set of all the x's, and the range is all the outputs and all the y's, if we talk about these as large sets of numbers. The good news is domain and range are in alphabetical order, just like x and y, just like input and output, so that will help you remember. All right, use the graph to answer the following questions. Is g of x a function? Well, we can test that with this little vertical line. It looks like where I move this vertical line, the vertical lines are only going to cross once. So it appears that, yes, it's a function. Is it one-to-one? I should test that with a horizontal line. And this horizontal line, oh, look, the horizontal line would possibly cross this thing twice. So I would answer those things this way. Is it a function? Yes. Is it one-to-one? No. It's a function, yes, because it passes the vertical line test, but it's not one-to-one because it fails a horizontal line test. And this function is kind of interesting, or this relation, or whatever we want to call this, is kind of interesting at first because it doesn't go on forever. It just kind of ends here and here with these little meatball points that they put on there. Daniel, whoever Daniel is, thinks that the domain for g of x is just this list of little numbers. Well, no, he's not correct because this is a nice continuously drawn curve. So there are values in this list. If you were to kind of list out the xy pairs that are true here, we would get values that are, lots of values are in between these. So there is such a thing as negative 1.5 in this function. There's a pi. There's all kinds of crazy square root of 2, not just these like 7 or 8 different numbers. So the actual domain for g of x, you could kind of say, well, it's all the x's from -2 to 4. So it's it starts at -2 and it goes all the way to 4. So those are all the x's that are involved in this, and that actually lists all the numbers as a way to kind of describe all the possible x's and not just this stuff. Which y values are valid for this graph? Well, same kind of thing. Now I have to look from kind of bottom to top. The smallest value looks like it's -1, and the largest value looks like 3. So I can write that way. There's other ways to write this. There's also some technicalities about how you observe things on a graph, and we'll get into that later, but for now, that should satisfy you. All right, here's one of those ways. Like, let's talk about interval notation. How do you write this and be really technical about what you're including and excluding and all that kind of stuff? Okay, so we've hinted at this a little bit earlier in the year. I told you there'd be an official time when I really wanted to hold you accountable for these things. This is that time. Okay, so we might be using things like positive or negative infinity. We might be using round brackets or square brackets, but basically these intervals. So this is called interval notation. It looks like a coordinate, I know, and I know that's frustrating and silly a little bit, but I didn't make that up. It's used by we use it in AP Stats. I mean, it's used all the time. It's just kind of a little bit strange to get used to. So this represents, you have to put the small number first and the larger number second. This represents a range of numbers. Instead of saying, okay, let me just do this. This is equivalent to saying this actually. So it's like saying, and I put X here because it's domain. The notation here doesn't actually really kind of specify that we're talking about X. It's just I wanted to show you what this would look like if I was going to use X and less than symbols. So you always put the lower number on the left and the higher number on the right. And the square bracket, and you can read this up here, the square bracket means we're going to include that number that's by that device over here. This round bracket means we're not going to include that, so that's the same way we used to do it this way. So these are equivalent ways to represent domain. It's just they're trying to teach you about this type of notation in Algebra 2. And why does this happen to be the domain that goes with this graph? Well, notice what's going on in the graph. We are counting this little filled in, I call these meatballs. There's a filled in meatball here at the x value of 0. And here we know it stops before it gets to the x value of 4. So this domain includes every number up to 4, but not 4. So it's like less than 4 strictly. It's not 4 included. The range, let's do that. That looks like it's starting. Again, we have a meatball down here. When they put a meatball on graph paper like here, you can be pretty sure that that means this is exactly -2. So we're going to go from -2, and then how high do we go? Well, since 3 is included by this meatball, it is part of the range. So I am going to include the -2, and I am going to include the 3. And so just to show you what that would look like if we were using the old, alligator notation here, is that's we use the square brackets, and we would have the equal to line on there. So that's the equivalent version in terms of y's. All right, domain and range here, same thing. So domain is going to be the set of x. It looks like x starts here at -infinity. And it because they didn't show an arrow here, but they're going to tell you later that when this hits the edge of the graph paper, it means that we're going to infinity that way. And then we're going to stop up here at 5. Hope you can see that. I'm trying to draw this with a mouse, but that's -infinity, 5. Whenever you use infinity, I think it says back here. Whenever you use infinity, we always use the round brackets. Maybe it says that later. Infinity is never a thing you can actually include, so we always, with infinities, it's always a round bracket, which is easy to remember because infinity is always a very curvy symbol. And we stop up here at 5, and from the range, it looks like we go from 0 upwards. And this, again, this implies that we're going to keep going up to infinity. It's not going to curve back down if they draw it this way. And again, infinity is not included, so I mean, I can use the idea of infinity here, but I have to use a round bracket to say that's where it's stopping. And this looks like a solid meatball, so I'm going to include the 0 in the range. I'm going to include the 5 in the domain. This one looks like a half circle. The domain here looks like it starts just after -2 and goes up to +4. Is that +4? Oh, strange. I guess. Oh, look at the scale here. That's 3, and this is actually -1 if you look closely at where those tick marks should be. Okay, so I'm not going to include the -1 in the domain, but I do include the 3. The 0 I included in the range because this has a value of 0. Now I can see this being a little controversial. Can we really tell if 2 is involved in this range or not? Like, what's the maximum point of this thing? And again, from these graphs, if it does this and it appears to include that 2, and it really looks like it, this seems different than the rules that we had for geometry diagrams, I know. But this is a graph and this is algebra, and it's actually a little bit easier if you go ahead and assume this kind of thing. If it's a turnaround point, I will actually on my test try to remember to put a little meatball there. You'll see on mine, I'll actually put, see, this is way too fat. I'll actually put a little thing right there. Whenever you see that, you can really be sure that yes, it is going to be like that. I try to make it so, you know me, I try to make it so it's not as controversial on my tests. So look for that. All right. Note, whenever there's a break in the domain, write an interval for each part of the domain. Then put the union sign between each. Okay, so we'll do that. So the domain here is a little tricky because it seems to go to -infinity and +infinity at the extremes, but there's definitely a hole here. There is no 1 in this relation or function. There's no value if you put x into it, if x is 1. So we have to indicate that in the notation. So the two intervals we're talking about are from -infinity up to 1 and from 1 to infinity. And so that kind of shows that there's, by showing these round brackets here, that's showing that 1 is not in either one of those intervals. And then the union sign they're talking about here, the union sign is the little u. The nice thing about union sign and the letter u is that union starts with u. I will just use union for all these. Whenever you have multiple Intervals you want to string together, we're going to string them together with union, which also means or. So it's like saying x could be in here or x can be in that. It also, because it's an or, it means like it's like accumulating these intervals into one large kind of superset that we're talking about. So we're going to want to use the union symbol, not the intersection symbol. Intersection symbol means it has to be in both. That doesn't make sense here. All right, and then the range here